Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will talk about the argument of a non-zero complex number. Before we begin, notice that the title is Argument of a non-zero complex number because in fact 0, which is a complex number, doesn't have any argument. Let's see the meaning of an argument. We have a complex plane orthonormal system. Z equals a plus ib. A and b are two real numbers. The argument of z with image MAB is the oriented angle UOM plus 2k pi. So the argument is an angle. It's an oriented angle between U and OM after we locate M in the orthonormal system. And the argument is denoted by small a, small r, small g. We open parentheses, we write z, then we close parentheses. In each of the cases below, locate the point in the coordinates plane and give a measure of argument of z. So we need to locate the point and give an argument. Let's begin with za, which is 1. In fact, in this case, A would be the point whose coordinates are 1, 0, that's it. And if we need its argument, go back to the definition. It's the oriented angle between U and OA, and the angle in this case between U and OA would be 0. Let's see the second case. ZB is -3. We write the coordinates, which are -3, 0. That's it. This is B. And the argument of ZB in this case would be the angle between U and OB, which is this angle. It will be pi plus 2k pi. Now ZC is negative radical 3. We locate it. That's it. And then the argument in this case would be pi. And ZD is 2 radical 2. This is the location of D, you see. And the argument in this case would be 0 plus 2k pi. Now let's continue. ZE is I, so E would be the point whose coordinates are 0, 1, and the argument in this case would be plus pi over 2. Remember, it's an oriented angle. Now ZF is minus 2i. This is F. This is point F if we locate it. And the argument in this case would be the angle between U and OF, which is somewhere here. It will be negative pi over 2 or 3 pi over 2. Now ZG is I radical 2. This is G after we locate it, and the argument would be pi over 2 plus 2k pi. And finally ZH is minus 3i. That's it. This is H, and the argument would be minus pi over 2 plus 2k pi or 3 pi over 2. Now try to notice here that if the complex number is a real number, then its argument would be either 0 or pi, depending on whether the complex number is positive or negative. If we have a positive real number, the argument would be 0, and if we have a negative real number, the argument would be pi plus 2k pi. Whereas if the number is positive pure imaginary, its argument would be pi over 2 plus 2k pi. And if it's a negative pure imaginary, its argument would be negative pi over 2 plus 2k pi. Let's see how do we determine the argument of Z. Z is A plus IB. MAB is the image of Z. Argument of Z is going to be denoted by theta, which is the oriented angle between U and OM. This is M. This is theta, you see, that's it. Now to calculate theta, we use cosine theta is A over the square root of A squared plus B squared, and sine theta is B over the square root of A squared plus B squared. And this is in fact happens because the triangle OM and P, if P is a point somewhere here, is a right triangle. Now we have to take into consideration the position of M in the plane. We're going to see the meaning of this statement now. So this is what you have to remember. The modulus of z is the square root of a squared plus b squared. And to calculate theta, you need cosine theta, sine theta, and the position of point. Let's see this example. We need to find the modulus of z and an argument of z in each of the following cases. This is the trigonometric circle that we're going to use. ZA is 1 minus I. Now, if we locate it, this would be A. So this is theta, which is negative pi over 4 graphically. Let's see how do we find it algebraically. As I said here, first we find the modulus of ZA, which is the square root of 2. Then we find cosine theta and sine theta, which are a over the square root of a squared plus b squared and b over the square root of a squared plus b squared. This is what we get. In fact, we need the cosine to be positive and the sine to be negative. So we are in the fourth quadrant. And from here, we can also see that A is located in the fourth quadrant. So the angle that we're going to get is going to be multiplied by A minus. Now, how do we find the angle? You come here to cosine theta and sine theta. You ignore their signs and then you use the calculator to see what is theta. Now, find theta such that cosine theta is radical 2 over 2. If we use the calculator and we write cosine inverse of radical 2 over 2, we're going to get pi over 4. And because of this minus, we multiply the answer by a minus. So theta is minus pi over 4. Well, this is a little bit complicated, but with more examples and more practices, you're going to see that it becomes easy. So we find cosine theta and sine theta for two purposes. First, in order to specify the position of the point in the quadrant. So here we could specify that it's in the fourth quadrant. So we have to find a certain value and then multiply it by a minus. How do we find this value? We use the calculator. Let's see another example to clarify the idea more. This is ZB. If we locate it, it's somewhere here. You see it's in the second quadrant. This is theta, this is the required angle. And in the second quadrant, this means that we are with pi minus alpha. Now, if we find the modulus of ZB, we get 2 cosine theta, sine theta. You see here the cosine is negative, the sine is positive. So this verifies that what we got before is correct. We are here in the second quadrant with pi minus alpha. So we find the angle using the calculator, then we subtract it from pi. Well, now we try to find an angle whose cosine is radical 3 over 2 and whose sine is half. Try to ignore the signs here. So the angle whose cosine is radical 3 over 2 and sine is 1 over 2 is pi over 6. So the final answer would be pi minus pi over 6. Remember, the angle that we find it using the calculator is going to be represented by alpha, whereas the answer in this case is pi minus alpha. Let's see the third case. This is ZC. If we locate it, we get negative radical 2, negative radical 2, which is in the third quadrant graphically. Now, this would be theta in blue. If we find the modulus of Z, it will be 2 cosine and sine. The cosine is negative, the sine is negative. This verifies that the quadrant is the third quadrant, which means that we need pi plus alpha. Remember again, alpha is calculated using the calculator. We need an angle whose cosine is radical 2 over 2 and sine is radical 2 over 2. Ignoring these two minuses, so the angle would be pi over 4. This is alpha, and theta would be pi plus pi over 4, which is 5 pi over 4, or negative 3 pi over 4. Now, we're going to see all of these details using the calculator. This is the calculator. Remember first to translate it into complex, mode, complex. By now the calculator understands complex numbers. I need to find the modulus and an argument of, let's say, 1 minus I. I just write 1 minus I, this is equal to, then if we come to shift and complex, this one above 2, we can get the argument alone, we can get the conjugate, we can get the algebraic form, and we can get the modulus and the argument at the same time with this sign. So if we press on 3, we get the modulus is radical 2 and the argument is negative 45. Now, in fact, the unit that is used in the calculator by now is the degree, as you see here, D. So we can also translate it into radian by pressing on Shift, Mod, Rad 4. So you see here we have the letter R, and in our case here, the modulus is radical 2 and the argument is negative pi over 4. Let's see the second case, which is ZB. This is AC. We have negative radical 3 and then plus I. This is equal to shift complex. We need the modulus and the argument. 3 equals, remember the modulus is R and the argument is theta, so the modulus is 2 and the argument is 5 pi over 6. And for the third case, we have negative radical 2 minus I, also radical 2, this is equal to, then shift 2, 3 equals, the modulus is 2 and an argument is negative 3 pi over 4. Now, which method is more preferable? Of course, the calculator is more preferable because it saves time. Now, let's continue applying. We also need to find the modulus and an argument of Z. The first case, ZA is 1 plus I radical 3. That's it. It's in the first quadrant. So the angle in this case is called alpha. Well, the modulus is 2. The cosine is positive. The sine is positive. So we are in the first quadrant. We need an angle whose cosine is half and sine is radical 3 over 2 using the calculator. This angle is pi over 3. Now, ZB is 2 minus 2I. That's it. This is the red angle. So the modulus of ZB is 2 radical 2. The cosine is positive. The sine is negative. We are in the fourth quadrant minus alpha. And theta is negative pi over 4. I will remind you again and again, this could be done using the calculator in a very simple way. Now let's see this activity. Z1 is A plus IB. A and B are two real numbers. M1, M2, M3, and M4 are 4 points. Argument of Z is theta. We need to find in terms of theta argument of Z1 bar, argument of minus Z1, and argument of minus Z1 bar. This is M1. These are A and B. This is OM, and this is angle theta. Now, this would be M2, which is A minus B, because M2 is represented by Z1 bar. This is A, this is minus B. We saw this before. We do have the same modulus, but according to the argument, we can see from here that the two arguments are not equal. In fact, one of them is the opposite of the other one. So we can state that argument of Z1 bar is minus theta, which is minus argument of Z. Now for M3, this is M3, and this is OM3, and this is the required angle, and as you see it from here, it will be pi plus theta. This is theta, and we need to add pi. So what is argument of minus Z1? It will be pi plus theta, or pi plus argument of Z. And finally, minus Z1 bar, this is the angle, so it will be, as you see, from here, in order to remove the minus, we add pi. So if we want to remove this minus, we add pi. We get pi plus argument of Z1 bar. And from the first case, in order to remove the bar, we multiply by a minus. This becomes pi minus theta. So here you have to memorize that in order to get rid of a bar, you multiply by a minus. And in case you have a minus inside and you need to remove it, you add pi. This is exactly the same as the oriented angles, because in fact the arguments are oriented angles. Now let's see the properties. We have argument of z bar is minus argument of z, argument of minus z is pi plus argument of z, and as a consequence, argument of minus z bar is pi minus argument of z. Let's see this example. Z1 is a complex number such that argument of Z1 is 7 pi over 12. The question is to determine a measure of each of the following arguments. Well, argument of Z1 bar is minus argument of Z, applying this property, so it will be negative 7 pi over 12. Now argument of minus Z1, applying this property, this would be pi plus argument of Z1, so pi plus 7 pi over 12, which is 19 pi over 12, or if we subtract 2 pi, we get negative 5 pi over 12. And the third case, argument of minus Z1 bar, this is the same as this case, so it will be pi minus argument of Z1, so this is pi minus 7 pi over 12, which is 5 pi over 12. Now try to apply, in this case, try to find each of the following arguments. Well, argument of Z2 bar is minus argument of Z2 is pi over 7. Argument of minus Z2 is pi plus argument of Z2, which is 6 pi over 7. And argument of minus Z2 bar is pi minus argument of Z2, which is 8 pi over 7, or minus 6 pi over 7 if we subtract 2 pi from 8 pi over 7. Now z and z prime are two complex numbers. Argument of z prime would be argument of z plus argument of z prime. Argument of z to the power n would be n argument of z. Argument of z over z prime would be argument of z minus argument of z prime plus 2k pi, where z prime is never 0. And argument of 1 over z would be argument of 1 minus argument of z. And we know that argument of 1 is 0, so this would be minus argument of z plus 2k pi, where z is never 0. Now, in these cases, as you see, they look like the logarithm, if you remember. Now, let's see here this example. We know that argument of z1 is alpha and argument of z2 is beta plus 2k pi. We need to find argument of z1 cubed z2 to the power 5 in terms of alpha and beta. If we just apply these properties and the previous ones, argument of z1 cubed z2 to the power 5, we have multiplication in between. The multiplication is translated into addition. This is argument of the first plus argument of the second. And here, in case we have an exponent, we put the exponent outside. So this becomes the 3 argument of z1, and this becomes 5 argument of z2, which is 3 alpha plus 5 beta plus 2k pi. Now, this is what we have to remember so far. Okay, argument of z1 is alpha, argument of z2 is beta. Z is this ratio, find in terms of alpha and beta argument of z. Try to do it alone and pay attention. Well, argument of z, this is division, so if we apply this property here, it will be translated into subtraction. So this is the argument of the numerator minus the argument of the denominator. For the numerator, we have multiplication in between, so we translate it into addition. Minus, in order to get rid of this minus and this bar, we apply the property, what is argument of minus z1 bar? It's pi minus argument of z1. Then we continue, this exponent becomes 2 and this exponent becomes 3, and here we remove the brackets. This is what we get, so this would be 3 alpha plus 3 beta.